From the earliest times, humanity felt the intrinsic need to represent the space around it. Even before writing great cities or empires, knowledge of the territory was vital for survival. Hunter-gatherers needed to know where to find food and water, where dangers lay, and safe passages. Nomadic groups relied on the memory of rivers, mountains, and migration routes. The map, in its most rudimentary form, was born from this primal need for orientation and record-keeping. The first maps were not complex works of art, nor were they drawn on parchment. They were simplified representations etched onto available materials, stones, bones, tree bark, or even scratched into the sand. One of the oldest known examples is a mural found in Cataluyuk in modern-day Turkey, dated to around 6200 BCE, which some archaeologists interpret as a map of a city with an erupting volcano in the background. Although its nature as a map is debated, it illustrates the human capacity to visually represent its environment. In ancient Mesopotamia, the cradle of some of the first civilizations, the need for maps was even more pressing. With the development of agriculture and land ownership, the demarcation of fields and water management were crucial. Sumerian and Babylonian clay tablets, dating back thousands of years BCE, contained the clearest records of the first maps. The Gosser map, a Babylonian clay tablet from about 2500 BCE, shows mountains, rivers, and cities, with annotations in cuneiform script. It wasn't a precise geographical map, but rather a property or resource map, showing specific areas for administrative and taxation purposes. The Egyptians, masters of surveying due to the annual Nile floods that redefined field boundaries, also produced maps. Their best-known maps, though few have survived, were frequently used for construction, planning, and mining exploration. The Turin Papyrus, from the 12th century BCE, is a notable geological map detailing a gold mining area, showing roads, mountains, and mines, with color indications for different rock types, a feat of thematic cartography. These early maps were egocentric, focused on the observer's known world. They reflected a limited, but important, understanding of the immediate space. Precision was sacrificed in favor of functionality. The need to hunt, gather, trade, wage war, and establish boundaries was the engine of cartographic innovation. These rudimentary maps were not just navigation tools, they were extensions of a community's collective memory and knowledge, transmitting crucial information about the territory in a visual and intuitive way. They paved the way for a more sophisticated understanding of the world. If the first spatial representations were dictated by immediate necessity, the cartography of the ancient world, especially with Greek and Roman civilizations, began to incorporate philosophy, mathematics, and astronomy, elevating the art of map-making to a scientific level. The ambition not only to represent the local environment but the entire world began to flourish. In Egypt, besides maps of mines and properties, understanding the Nile and its flood cycle was fundamental. Egyptian surveyors, known as rope stitchers, developed sophisticated techniques to measure and demarcate land after floods, using rudimentary geometry to create cadastral maps, essential for taxation and land administration. While they did not produce world maps, their precision on smaller scales was impressive. The true revolution in cartography, however, came with the Greeks. Their philosophers and mathematicians were not content with just describing. They wanted to understand the why of things and the shape of the universe. The concept of a spherical Earth, proposed by thinkers like Pythagoras in the 6th century BCE and Aristotle in the 4th century BCE, was a landmark. This idea fundamentally changed how the world could be mapped. One of the pioneers was Anaximander of Miletus in the 6th century BCE, who is credited with creating one of the first known world maps. Though primitive, it attempted to represent the inhabited world, the oikoumene, with Greece at its center. In the 3rd century BCE, Eratosthenes of Cyrene, director of the Library of Alexandria, was even more remarkable. He not only accepted the spherical Earth but calculated its circumference with astonishing accuracy, using the difference in sun angles in different cities. Eratosthenes also developed a coordinate system with lines of latitude and longitude, a precursor to modern systems, creating a more precise world map. In the Roman period, cartography gained a more practical and military application. Romans, engineers and administrators par excellence, needed maps for the administration of their vast empire, the planning of military campaigns, the construction of roads, and the organization of trade routes. Their maps were more pragmatic than the philosophical Greek maps. The map of Agrippa, a gigantic work commissioned by Augustus in the 1st century BCE and publicly displayed in Rome, showed the Roman world and its roads, a precursor to road atlases. Although it has not survived, texts describe its grandeur. Road maps, like the Tabula Peutingera, a medieval copy of a 4th century CE Roman map, show routes, cities, and distances, serving as practical guides for travelers. Geographical precision was not the priority, but rather functionality and route detail. The pinnacle of ancient cartography was reached with Claudius Ptolemy, a geographer, astronomer, and mathematician who lived in Alexandria in the 2nd century CE. His work Geography was a revolutionary compendium. Ptolemy compiled all geographical knowledge of the Greco-Roman world, listing about 8,000 locations with their latitude and longitude coordinates. He introduced the idea of cartographic projections, ways to represent the Earth's spherical surface on a flat surface, albeit with inevitable distortions. His world maps, which stretched from Western Europe to Asia and Africa, would form the basis of Western cartography for over 1,000 years, even influencing the Age of Discovery. The legacy of these ancient cartographers was the transformation of the map from a simple local representation to a universal tool, based on mathematical principles and astronomical observations. Although still with many inaccuracies, these maps were humanity's first serious attempt to understand and visualize the world in its entirety, paving the way for discoveries that would come centuries later. With the decline of the Roman Empire, cartography in the West underwent a period of slower development, often reverting to more theocentric models, where the world was represented through religious lenses, with Jerusalem often at the center. Medieval European maps, known as Mappa Mundi, were more symbolic and encyclopedic than geographically precise. They blended biblical information, legends, and fragmented geographical knowledge, serving more as moral tools or visual narratives than navigation guides. However, in other parts of the world, the flame of cartography continued to burn brightly. The Islamic world, with its vast trade network and its appreciation for mathematics and astronomy, maintained and expanded geographical knowledge. Cartographers like Al-Idrisi in the 12th century, serving King Roger II of Sicily, produced remarkably precise world maps for the time, such as the Tabula Rogeriana, which included vast portions of Africa, Asia, and Europe, far surpassing the precision of contemporary European maps. The necessity of the Hajj, the pilgrimage to Mecca, also spurred the development of detailed maps and route guides. The true revolution in cartography, however, would be driven by maritime navigation and the European longing for new trade routes and unknown lands. The Renaissance, starting in the 14th century, brought a renewed interest in classical knowledge and exploration. The invention of the movable type printing press in the 15th century democratized map production, making them more accessible and amplifying their dissemination. A crucial milestone was the development of Portoland's detailed nautical charts that emerged in the Mediterranean from the 13th century onwards. These maps, focused on rum lines and ports, were extremely practical for sailors, with precise information about coastlines, islands, and depths. They represented a leap from Mappa Mundi, prioritizing functionality over religious symbolism. The Age of Discovery, initiated in the 15th century by Portugal and Spain, transformed cartography forever. The need to plot safe routes to Africa, India, and later, the Americas, spurred unprecedented technological and cartographic innovations. Instruments like the astrolabe and the quadrant allowed navigators to determine latitude with greater accuracy, while the invention of the Davis quadrant and the improvement of the compass and the tiller stern rudder made long-distance navigation safer. Maps of new lands were eagerly awaited and guarded as state secrets. Navigators like Bartolomeu Dias, who rounded the Cape of Good Hope in 1488, and Vasco da Gama, who reached India in 1498, and of course, Christopher Columbus, who reached the Americas in 1492, and Ferdinand Magellan, who led the first circumnavigation of the globe, beginning in 1519, contributed important data that would redefine the world map. The world revealed itself to be larger and more complex than imagined. The 16th century saw the emergence of legendary figures in cartography. Gerardus Mercator, a Flemish cartographer, revolutionized cartographic projection in 1569 with his famous Mercator projection. This projection, which preserves the shapes of continents but distorts their areas as they move away from the equator, was crucial for navigation, as it allowed a constant bearing line to be represented as a straight line on the map. Despite its distortions, the Mercator projection became the standard for nautical maps for centuries. The Age of Discovery transformed the map from a tool of local knowledge to an instrument of global power. Maps were not just representations. They were guides for conquest, trade, and colonization. They spurred exploration and, in turn, were shaped by it, revealing an increasingly vast and interconnected world, a testament to human curiosity and ambition. With the Age of Discovery mapping continents and oceans, cartography continued its journey of refinement and precision. In subsequent centuries, the development of new technologies and the tireless pursuit of greater accuracy would radically transform how the world was represented. The invention of the maritime chronometer by John Harrison in the 18th century was a watershed moment. This technological innovation allowed navigators to determine longitude with unprecedented precision, solving a challenge that had plagued sailors for centuries. This, in turn, led to the creation of much more reliable nautical maps, essential for maritime safety on the high seas and for the flourishing of global trade. Navigation became a more exact science, reducing shipwrecks and optimizing routes. The 19th century witnessed the emergence of large-scale systematic topographic surveys. Governments and militaries of European powers, such as Great Britain and France, invested heavily in detailed mapping of their territories and colonies, aiming for administrative defense, tax collection, and infrastructure development purposes. Aerial photography, developed in the early 20th century, further revolutionized data collection for maps. This technology allowed for the creation of maps of vast and hard-to-reach areas with unprecedented speed and detail, overcoming the limitations of traditional ground-based mapping. The true turning point for cartography, however, came with the digital age and space technology, starting in the second half of the 20th century. The development of powerful computers, the launch of artificial satellites into Earth's orbit, and the creation of global positioning systems changed everything. The emergence of the Global Positioning System (GPS) in the 1970s and its popularization from the 1990s onwards represented a revolution. It allowed anyone with a receiver to determine their exact location anywhere on Earth, with precision down to meters or even centimeters. This, in turn, democratized access to geographical information and navigation tools that were previously exclusive to military personnel and scientists. Remote sensing, the collection of data from the Earth's surface via satellites and aircraft equipped with advanced sensors, provided an unprecedented amount of geographical and environmental information. Geographic Information Systems (GIS) software allowed this raw data to be stored, analyzed, visualized, and overlaid in complex and highly customizable ways. Maps were no longer just static paper representations. They became dynamic, interactive, and filled with layers of information that could be updated in real time. This ability to integrate and analyze different spatial datasets opened new frontiers for various fields of knowledge. Today, we live in an era of real-time and ubiquitous cartography. Map applications on our smartphones guide us through unfamiliar streets, show us traffic conditions, locate restaurants, hospitals, and provide instant weather information. Digital maps are indispensable tools for urban and regional planning, natural disaster management, environmental and biodiversity monitoring, autonomous vehicle navigation, and even for understanding patterns of disease or social inequality. Cartography has become an essential tool in almost every aspect of modern life, from global logistics to cutting-edge scientific research. The legacy of cartography is one of an incessant quest for knowledge, understanding, and control of space. From primitive lines scratched in clay, through the portals of audacious navigators, to high-resolution satellite images, maps are tangible proof of human curiosity in deciphering its environment. They transform the way we see the world, allowing us to explore the unknown, build vast cities, and connect distant cultures. Maps gave us power over space and the ability to dominate geography, but they also revealed our smallness before the vast and complex tapestry of our planet. It is a continuous process of learning and discovery, where each new map opens the way for new questions and new explorations. The saga of maps is the story of humanity itself, our journey to go beyond the next mountain, to navigate unknown oceans, and, finally, to see the entire world in ever greater detail, from paper to pixel. The act of mapping is, in its deepest essence, the act of understanding and organizing our place in the cosmos. And cartography continues to be our most powerful lens for seeing, navigating, and interacting with the complex and fascinating stage of our planet. The history of cartography is a fascinating journey that has taken us from primitive scribbles to the complexity of GPS in our pockets. Which invention or period in map history do you consider the most revolutionary, the one that most impacted how we see and interact with the world today? Have you ever gotten lost relying on a map or navigation app? Share your opinion in the comments and join our discussion about the power of maps. And if there's another saga of discoveries, an innovation that changed the world forever, or a topic you'd love us to explore in our next video, leave your suggestion below. Your curiosity is our guide to unraveling the great stories of the world, and the next adventure begins with you.